So I would again like to start today off by looking at an example problem. So I have a feeling that maybe this one on the table might have been a little bit tricky. So if you're looking at the one on the table, of course my answers are right in front of us here because this is the teacher's guide. When you're looking for the zeros, and they're going to be between two values, when you're looking at these tables, in case you're wondering how on earth you're supposed to come up with a zero, you're looking at these values whether they're positive or negative. So here's a positive value, positive, positive. That means that my function is still above the x-axis at this point. And then when it switches to being negative, that's when we're down below. So at some point between 0 and 1, my graph switched from being above the x-axis to below the x-axis, which means it must have crossed through the x-axis. So the first 0 is somewhere here, and then I'm negative, that's still below. And then at some point here, my graph went from below the x-axis to above, so it happens again between 2 and 3. I also would like to look at number 33, because I bet that was probably tricky. Let me get a piece of paper. Here we go. Okay, so this one that we're going to look at, this is number 33, just so we can get a sample of what we're doing here. We're looking at number theory. So it says their sum is negative 15. So we've got our first number, and then knowing that their sum is negative 15, we can take negative 15 minus x, and that's what the other number will be. Because that's if you add them together, you get a sum of negative 15. So hopefully you guys were able to model this one off of the one that we did in the notes. And their product is a negative 54. So we take x, and then multiplied by this other number, our product comes out to be a negative 54. So just like we did in the notes, we're going to clean this up a little bit, first by distributing the x. So we distribute the x, we get a negative 15x minus x squared equals a negative 54, and then we're going to get this into standard form, which first of all just involves rearranging these two, because we're used to seeing the x squared term first, then the x term, and then we are going to add the 54 to both sides, so that we can get it into standard form, because remember from yesterday, standard form means that you have 0 on one side. So let's take a look. We're going to go into a graph. This is how we solved these the other day. So in a graph here, we are going to plot this function. So we've got a negative x squared minus 15x plus 54. So let's plot that just to see what we come up with. So here's one of our numbers that pops in here. So that's 3. So before we zoom around and see if anything else works, let's take a look at the 3. So x equals 3 is one number that we came up with. So let's plug that in right here. So the other number would be negative 15 minus 3, which is a negative 18. So let's see if these two numbers work. So 3 and negative 18, let's check them against our two conditions that they gave us. Their sum is negative 15. That's true. If you add them together, you get a negative 15. And their product is negative 54. That is also true. If you multiply them together, you get a negative 54. So that's just one sample homework problem. Now I want us to go into the notes. So we are looking at 4.3. So make sure we've got these out. We're going to start with the definition. This is the factoring method. So far we have solved quadratic equations just by looking at the graph. First couple of days we were learning exactly how to graph them, and then we looked at our calculator just to solve, is there one solution? Are there two? Are there no solutions possibly? We're going to do this time like an actual algebraic method to figure out exactly how to solve these. So we're going to start with standard form, which actually begins with what we call factored form. So factored form of a quadratic equation looks like this. It is a, and then in parentheses we have x minus p, and then in parentheses again we have x minus q, and this equals 0. We're pretty used to standard form having to equal 0, so let's kind of walk through exactly what all of these things mean. So a is just going to be a constant. So we might have like, a 2 out front, or we could have a negative 3 out front, or something like that. The important part is that I have this x minus p, x minus q. You might be wondering what on earth p and q are supposed to be. Well, in the equation, p and q, those two numbers, they represent the x-intercepts. There we go. P and Q represent the x-intercepts. So the whole goal with our last lesson was to find where the x-intercepts are. We looked at the graph and we saw, oh, it crosses the x-axis there and there. Those were the x-intercepts, and the x-intercepts ended up being our solutions. So this factored form would be super convenient if we're trying to figure out what the x-intercepts are, because if we get it into this form, we just look at P and Q, and there they are. There are our x-intercepts. So we can use FOIL. I'm sure you guys remember FOIL, first, outer, inner, last. So let's recap this really quickly. The example that we're going to look at, so we're trying to get something from factored form into standard form. So to multiply the binomials, we'll look at an example here because I really think that that's the best way to do FOIL. So let's look at x minus 6 and then x minus 2. So this represents factored form. That's what we were talking about here. So here x minus p is x minus 6, and then x minus q is x minus 2. So that means that 6 and 2 would be my x-intercepts. But like I said, I'm interested in getting this into standard form, not in leaving it in factored form like this. So what I'm going to do is I'm going to do the FOIL method. I'm going to color code a little bit for you. So F stands for first. So I multiply the first two values together. I multiply the x times the x. And so we're going to get a little practice with multiplying here. So x times x gives me x squared. Next, I am going to multiply the outside numbers. That's what the O stands for. So I multiply the outside two together. X times negative 2, don't forget about your sign, would be a negative 2x. Next, the I stands for inside. So I'm going to multiply the inside two together. So I do negative 6 times x, and that would be a negative 6x. And then lastly, I am going to multiply the last. So L for last, I multiplied the last two numbers together. So negative 6 times negative 2 would be a positive 12. And then I'm going to simplify up all of my terms here. The middle two both have an x attached, so I can combine those up. So I end up with x squared. These middle two, when I add them together, I get a negative 2x and negative 6x. That is a negative 8x and then a positive 12. So this is standard form, your ax squared plus bx plus c. All right, so that's what we were doing, just kind of multiplying these two binomials together. So first example that we're going to look at, we're going to write a quadratic equation based on what its roots are. Now remember, we talked about this word the other day, roots as well as x-intercepts. Those are completely interchangeable. Zeros, I believe we talked about that as well. So zeros, roots, x-intercepts. I'm going to try to use them interchangeably so that you realize that there's more than one way to say a certain idea. So a root is the same thing as an x-intercept. It's where the graph crosses the x-axis. So they give us their roots. So we are going to just plug these two together, set up our standard form. So the pattern, the way that the pattern works is it's x minus p, x minus q equals 0. So we're going to replace our roots. So x minus, here's where I plug in the first x-intercept. It's 3/4. So x minus 3/4. And then in the next one, x minus the next one. So x minus a negative 5, let's change that to plus 5, equals 0. So now I'm going to work on that left-hand side. I'm going to do that FOIL method that I just talked about so I can get standard form. All right, so start with the first. First, I multiply x times x, and I get x squared. And then O for outside. So I multiply the outside two together. X times 5 gives me a positive 5x. And then I multiply the inside, I for inside. Multiply these two together. Negative 3/4 times x is just a lovely negative 3/4 x. And then the last, I multiply negative 3/4 times positive 5. So let's do, whoops, sorry. So negative 3/4 times x, times 5. So negative 3/4 times 5, that's the same as times 5 over 1. So just a little side work here. So I get negative 15 over 4. So then I have minus 15 over 4 equals 0. So we are just about done here. The only thing is we're looking at this. I don't like fractions. You don't like fractions. I don't know if any of us like fractions. So what we're going to do is we're going to multiply so that we end up with integer values. We don't want any fractions. So if we're looking at the denominators, we have denominators of 4. So in order to clear out those denominators of 4, we are going to multiply every single value by 4. And so let's write down what we get. So 4 times x squared, of course, is 4x squared. 4 times 5x gives me 20x. And now here's where we get to clear out the fractions. So 4 times negative 3 over 4, the 4's will cancel. And so I have negative 3x. And then the exact same thing will happen when I multiply these two together. When I multiply 4 times negative 15 over 4, the 4's will cancel out, and all I'll have is the negative 15. And then finally, the 0 is totally untouched. I can multiply 0 by anything I want. Last step is I'm going to combine up like terms. So I've got these two that both have an x attached. So I combine the 20 and the negative 3, and I get 17. So that is my equation in standard form. So remember, the equation is set equal to 0, not set equal to y. And then I'm not supposed to have fractions. We talked about standard form with lines. We're not supposed to have fractions in standard form with lines. That's the same thing with these, standard form of quadratics. So if I have fractions, just like I did here, I just multiply by the LCD, and it'll clear those fractions right out. So this is standard form. All right, so that's one thing that we can do. The next thing that we're going to do is we're going to jump right into this whole solving by factoring idea. So we're going to get some factoring practice is mostly what we're going to be doing today. So solving by factoring. It's an application of something called the zero product property. So let's write this down. So the zero product property, the main idea is if A times B equals 0. So if I know that a product is 0, if something times something else equals 0, then either A equals 0, B equals 0, or both. Could be possible that both A and B are equal to 0. So let's kind of think about that. If you're multiplying two numbers together and they get 0, one of them has to be 0. There's no way around it. So if I know that a number times a number is 0, again, one of them, maybe even both of them, must have been 0. It doesn't work with other numbers. Like, if a number times a number gave you 4, it doesn't mean that one of them had to be 4. It could have been 2 times 2 or something like that. So it only works with 0. So what we're going to do, like for example, so an example just to help us, let's say we know, so instead of A times B, we're going to write x plus 3 times x minus 5 equals 0. Then it must be true that x plus 3 equals 0 or x minus 5 equals 0. So that's the major step that we're going to take when we are solving by factoring. If we get something into factored form, which is the form that we were just talking about up above, then we kind of follow this zero product property. So it says if something times something equals 0, which is exactly what we have down here, something times something equals 0, then either the first thing is 0 or the second thing is 0, or of course both is always possible. So we set the first thing equal to 0 or the second thing equal to 0, and that's how we end up solving for x and getting our solutions. All right, so that's the main idea that we're going to be following. We're going to look at two of the factoring patterns today. So we're going to flip the page to our first pattern. So we're going to solve each one of these equations. The first technique that we're looking for is the Gcf technique. So in all of these, example 2, what we're going to do is factor out the Gcf. So just as a reminder, I know some of us probably know this, Gcf stands for greatest common factor. So when you're looking at a bunch of the terms, you will probably notice that they've got some things in common. So let's look at this one right here. We're in standard form because everything's on the left and there's just a 0 on the right. And if you look at these two terms on the left, 20x squared plus 15x, we start with the original equation. The first thing we're going to do is factor out the Gcf. Okay, so between these two, the largest thing they have in common, let's look at the numbers first. Between 20 and 15, the largest thing they have in common is a 5. And then between x squared and x, they both have a shared copy of x, so I can factor that out as well. Now when I say factoring, what's going to happen is it's almost like the opposite of distributing. You know how when you distribute, you multiply both things by a quantity? When you factor, it's like undistributing. So let's set up a set of parentheses here. I am going to undistribute the 5x. So if this ended up being a 20x squared, if I undistribute the 5x, it's essentially like dividing it out. So if I take this term right here and divide out a 5x, 20 divided by 5 leaves me with 4, and then x squared, if I divide out an x, I'm left with another copy of x. You can always double check this. If you were to redistribute that 5x, you'd land right back at the 20x squared. And then plus, now again, take that 15x and kind of undistribute a 5x, or in other words, divide. So 15x divided by 5x leaves me with just a 3. And same thing, like I said, we could redistribute that 5x and we would confirm that I do get the left-hand side. We don't want to. I factored it for a reason. So now 5x is one of my factors, and then 4x plus 3 is one of my factors. So I'm going to use that zero product property that I just talked about. If the product of these two things is 0, then it must be true that either 5x is equal to 0 or 4x plus 3 is equal to 0. So that is, again, called the zero product property. So now I'm just going to solve both of these equations. So with this one, the only thing I have to do is divide both sides by 5. Here the 5's will cancel. And 0 divided by any number always gives me 0. So that's one of my answers. Second answer, I've got a little two-step equation here. I'm going to subtract 3 from both sides. I get 4x equals a negative 3, and then divide both sides by 4. So I end up with negative 3/4 as my other answer. So two possibilities there. Either if x equals 0 or if x equals negative 3/4, then this equation will be equal to 0. All right, second one. We're going to do basically the exact same technique for these next two. They're already in standard form because you've got 0 on the right. So here between 4 and 16, the greatest number that we have in common is 4. This one has 2 copies of y. This one has 1 copy of y. So we can factor out 1 copy. And then we're going to divide out that 4y and then write the leftovers in parentheses. So 4y squared, if I divide out a 4y, I'm still left with a single copy of y. Plus, and then 16y, if I divide out a 4y, I am left with a 4. So again, follow the zero product property. I can set both of those little factors equal to 0. So if I set 4y equal to 0, or I could set y plus 4 equal to 0, and I'll get my two answers. So this one, just like up above, I just divide both sides by 4. So y equals 0 is one of my possible answers. Or here I can subtract 4 from both sides. So I get y equals negative 4 is my other possible answer. So either one of these, if I were to plug either one back in, it would make the equation true. Last one. Between these two, 6 and 18, the largest thing I can factor out is a 6. Because 6 and 18 are both multiples. And then a to the 5th, a to the 4th. They both share 4 copies, so I can factor out an a to the 4th. And then in parentheses, I'm going to write my leftovers once I divide out that, or 6a to the 4th. 6a to the 5th, divide out 6a to the 4th, all that's left is a single copy of a. And then 18a to the 4th, if I divide out 6a to the 4th, all the a's are gone, and I'm just left with 18 divided by 6, which is 3. So here's my first factor. I'm going to set both of those equal to 0. So here if I divide by 6, I get a to the 4th power equals 0. So that means that something raised to the 4th power equals 0. The only possibility would be 0. There's no way to raise anything else to the 4th power and end up with 0. And then my second one, I set a plus 3 equal to 0, and just like the one right above it, just a quick little one-step equation. And I end up with a equals negative 3. All right, so that is my first method. That is the factor the GCF method. Next thing I'm going to look at are trinomials and binomials that are perfect squares. And these have these special factoring rules. That's the next thing I'm going to look at. So we can take a look at these patterns that we've got here. Solving each equation, if we look at this, the pattern that we're looking for is that the first and the last terms are perfect squares. 4x squared is a perfect square, 9 is a perfect square, and in the middle term, this is a little weird, needs to be twice the product of the square roots. So here, the square root of this is a 2x. So we remember square roots. If I take the square root of that, I get 2x. If I take the square root of this, I get 3. So the middle term needs to be twice the product of the square roots. So 2x times 3 is 6. That is in fact twice the product, because keep in mind this could be a positive or a negative 3. Just square it and give me 9. So what I write is I'm looking for that pattern there. So x squared is 4x squared is 2x squared, so it's a perfect square, so is the 9. And then again, the middle term equals twice the product of the first and last terms, square rooted. So what I know is that it's going to be something called a perfect square trinomial. So I can write it out. So it's kind of like reverse foiling. So I know that it's like taking this 2x minus 3 and then squaring it. All right, so let's write this out. So 2x minus 3, just to confirm, I'm just going to show you that this actually works. If I do 2x minus 3, 2x minus 3, I'm going to factor it out and show you that you actually do get this. So if we do the first term, 2x times 2x gives you a 4x squared. Outside, 2x times negative 3 gives me a negative 6x. Inside, negative 3 times 2x gives me a negative 6x. And then for the last, negative 3 times negative 3 gives me a positive 9. So if I simplify that up, that is exactly what I started with here. So I know that 2x minus 3 squared must be the factorization. And then I still have a 0 on that right-hand side. So the first thing I do is I'm going to take the square root of each side, because I need to get rid of that squared. So I'm going to take the square root of the left, I'm going to take the square root of the right. This is a little bit of a recap from Algebra 1 or Algebra 2. When I square root something that's squared, those two things cancel each other out, and I just have a 2x minus 3. And the square root of 0 is definitely 0. So let's do a quick two-step equation here. Add 3 to both sides. So let's, work over here. So 2x equals 3, and I can divide both sides by 2. So x equals 3 halves. That is my one and only answer for this one right here. Okay, let's look at another one here. 81x squared and then minus 9x equals 0. So this one, what I want to do is I'm going to factor out the GCF. Always keep that in mind. There usually will be a GCF somewhere that you can kind of keep an eye out for. So these two, 81 and 9, they have a GCF of 9. And then x squared and x, there's one copy of x that I can factor out. And then in parentheses, again, I am going to write the leftovers. So if I take 81x squared and I divide out a 9x, what I'm left with is a 9x. And if I take 9x and 9x, I divide them, I'm not left with nothing, I'm left with 1. Because 9x divided by 9x leaves me with 1. Okay, so zero product property, just like I did up above. I'm going to take the 9x and set it equal to 0, or it's possible that the 9x minus 1 could be equal to 0. All right, so just the same as the first step up there. When it's just 0, I divide both sides. So x equals 0 is one possibility. Or here, I add 1 to both sides as a first step. So I have 9x equals 1, and then I'm going to divide both sides by 9 to get my nice fraction answer of 1/9. Okay, so one more of these for today. So this one again, take a look. Your first thing that you should look for should always be GCFs. All right, so between the two of them, between 6 and 3, the GCF is 3. And then between a squared and a, there's a common copy of a that I can factor out. So this one's going to be really similar to part B. In parentheses, I write the leftovers once I factor out the 3a. So when I take the 6a squared and factor out a 3a, what I'm left with is a 2a. And then when I take 3a and divide out a 3a, just like what happened up above, 3a divided by 3a, I still have a 1 there, so do not forget about that 1. So last thing, just like the last several problems, is I use that zero product property. I set the first term, I set 3a equal to 0, and then I set the second term, 2a minus 1 equal to 0. Okay, to get the a by itself here, I am going to divide by 3. 0 divided by any number is always just 0. We've learned that from the last handful of problems. And then here I do 2 steps, add 1, I get 2a equals 1, and divide both sides by 2. So a lot of these are just like little algebra steps that we're taking. There we go. All right, so there are my 2 answers for that. So I believe, yes, that is where I'm going to leave off for today. All right, work hard.